morning, this is Nimla Ratnam. In this video, we are going to discuss the sums from the exercise 9.1. We'll also look at the try these questions and the solved examples. In the previous video, we looked at the theory part where we figured out a way to find area of any given polygon by segmenting it into different, known areas like a triangle, trapezium and so on. And that is one method of finding area of any given polygon. So the first try these we had already looked at in the previous video. Let's look at the second one. Polygon ABCD is divided into parts as shown. Now they have given certain side lengths and certain not the side length, AD is the diagonal here. So they have given the length of this diagonal and also each of these feet of the perpendicular from the other three vertices. They have given the lengths here and also the length of the perpendicular that we are dropping from the other three vertices. Using this information, can you find the area of this polygon, which here in this case it's a pentagon. It has 5 sides. Okay, so let's look at it. First, let's draw the figure. In any geometry chapter, whenever you're solving, please remember that it's very important to draw the figure. Usually, if when you start the solution on the right side, using a scale and a pencil, it's very essential and very important to draw the figure along with the measurements given information, because in every step we will be referring to the figure. So it is advisable that you draw the figure. So here, let me draw the figure first. AD is my diagonal, right? And I have AB, BC and CD. And then I have E on the other side. So this is my pentagon and I'm dropping the perpendicular here, right? And the feet of the perpendicular are named FGH. Now let's quickly look at the information given to us. AD is given as 8 centimeters, right? This is 8 centimeters. And then they have given AH. AH is given as 6 centimeters. And then they have given AG. AG is given as 4 centimeters, right? And then I have AF. AF is given as 3 centimeters. AF is given as 3 centimeters. And also these heights have been given to us. They are 2, 3 and 2.5, right? So I have this one is 2 and then this is 3 and this is 2.5. So using this information, I have to find the area of this polygon, even though I don't have any formula, a set standard formula for finding area of a pentagon or any given polygon, right? So here you can see that I can segregate this into 4 parts. This here is very easy because I have the base and the height, so I can find area of this triangle. When you go to the above this triangle, you will see that there are 3 parts, 2 right angle triangles and 1 trapezium. This is a trapezium because BF is parallel to CH and FH is the height, the perpendicular distance between this parallel pair, and which can be found out from these given information. So I'm going to name them as 1, 2, 3, 4, right? And as you can recall, area of a triangle is half base into height and area of a trapezium is half h into a plus b. Okay, so I'm looking at the first segment ABF. Now the base is AF. You can see that AF is 3 centimeters. So half into base into height is 2 centimeters. So this is nothing but 3 square centimeters, right? Next, I have AED. This is the triangle we are talking about. Here I have base is AD, which is 8 centimeters, height is 2.5 centimeters, right? So this is 10 square centimeters. And then I have CDH. Now if you look at that, the base is DH. Now, do we know DH? If I know AH and AD and AH, if I find the difference between these two, this is nothing but DH, right? So this is nothing but 8 minus 6, which is nothing but 2. So that is my base and height is 3. So this is 3 square centimeters. Coming to the last segment, now this is a trapezium. You know that area of a trapezium is half into h into a plus b. Now what is h? FH. This is the height. FH is the height between the parallel sides. So FH is this length, which is nothing but 6 minus 3, which is 3. And then I have a plus b, 2 plus 3. A plus b is 2 plus 3, which is 5. So this is 15 by 2, 7.5 square centimeters. Therefore, the total area is nothing but sum of all these, which is 16 plus 7.5, 23.5 square centimeters. So this is your answer for the second try this question. Now coming to the third one, again they have given a pentagon and they have given a few no, it's not a pentagon, sorry, this is a hexagon. I have 6 sides here and they have given this particular diagonal MP and also the heights of the perpendiculars dropped from the remaining 4 vertices. So let's draw the figure first and then figure out how to find the area of this particular polygon, hexagon. So first I'll draw the diagonal MP, right? And I have 2 vertices on top, N, O, and I have 2 vertices on the bottom, R, Q, right? So now if I drop the perpendiculars, I'm going to name them as A, B, C, D. So now the information given to us is this length MP, length of the diagonal, is given as 9 centimeters. And then I have MD is 7 centimeters. And then I have MC as 6 centimeters. And then I have MB as 4 centimeters. And then I have MA is 2 centimeters. Right? So these are the different lengths given to us. They have also given the heights 2.5. This is also 2.5, 3, 2. Okay. So now in order to find area of this particular polygon, you can see that if I consider this as 6 different segments. Now these 4 are right angle triangles and these 2 are trapeziums. In that way, if I consider this, I will be able to find the area of this polygon. So let me name it 1, 2, 3, this is 4, this is 5 and this is 6. So again, area of triangle is half base into height and area of a trapezium is half h into a plus b. Let's look at this one. Half into base, MA is given as 2 centimeters, right? MA is 2 centimeters. So half into base into height is 2.5, right? So this is nothing but 2.5 square centimeters, right? If I look at the second part, again this is a right angle triangle and I have base is MB 4 centimeters and height is 2.5. This is nothing but 5 square centimeters. The third part is a trapezium. Now what is the height of this trapezium? BD. BD is from here to this part, right? So that is 7 minus 4. 7 minus 4 is 3. And A plus B is 4.5. right? Now this is 45 into 15, 6.75 square centimeters. That is the third part. Now the fourth part is my base is dp. dp is this length. This is dp. 9 minus 7 is 2, and height is also 2. So this is nothing but 2 square centimeters. Next, coming to the fifth one, again I have base cp. cp is nothing but 9 minus 6, which is 3. Height is also 3 centimeters square. So this will give me 4.5. Right, and then I have the last part, which is a trapezium. Now height is AC. AC is from here to here, which is 6 minus 2, which is nothing but 4. And then I have A plus B, which is 5.5. Alright, so this is nothing but 11 square centimeters. Right, now I have to find the area by simply adding all this. So I have 5 plus 2, 7 plus 11 is 18, and then I have a 10, 28, 30, and then 31 plus 0.75, 31.75 square centimeters. So that is the area of the given hexagon. Let's look at the example, solved example. Area of a trapezium is given as 480 square centimeters. The distance between the parallel sides, which is the height, is 15 meters, and one of them is 20. Let's say A is 20. Can you find B? Simply by equating this formula to 480 and then simplifying it, you can find the area of the, not the area, the side length of the other parallel side, right? So that is how the question can be asked. Next, I have the area of a rhombus is given as 240, and one of the diagonals. We discussed yesterday the area of a rhombus is nothing but half d1 d2. If this is half d1 d2 and one of the diagonals is given, you can find the other diagonal by equating it to the formula, right? So that is your second solved example. In the third example, they have given a hexagon MNOPQR, and they're saying that the side length is 5 centimeters, right? And also they are saying that these measurements are given. The distance from this side to this side is given as 8, and these two, if you join this particular diagonal, is given as 11. And here they're asking how can you find. Like I said, there's no unique way. You can do it in many ways. So here they have given two ways used by Ridhima and Aman. Ridhima's method is you are dividing it into two triangles and a rectangle, and Aman's way is simply joining NQ and getting two trapeziums, right? So you will see that both ways you will get the same answer, and you can actually try to find if there are any other ways of arriving at the answer, right? So that is uh, one interesting exercise where you will see that there is no unique way of finding area of a polygon. You can, as long as you have the necessary information given to you, there are more than one ways of finding the area. Although in this question, the way they have solved it, they are assuming that it's a regular hexagon and they haven't mentioned it here that it's a regular hexagon, but you can just make that correction. Consider it to be a regular hexagon, right? And just check if you can think of any other way of finding it, which is different from Aman's and Ridhima's method. Next, let's go to the exercise. Now here I have the first question. I have trapezium shaped table and you are supposed to find the area. This is quite simple. We can do it here itself. Half h into a plus b. We know the area of trapezium is half h into a plus b. Here I have half. Height is 0.8. A plus b is 1 plus 1.2, which is 2.2. So when I simplify this, meter square, right? This is nothing but 1.1. So I have 0.88 meters square. So that is the answer, right? So Second question, area of a trapezium is 34 square centimeters. Length of one of the parallel sides is given, height is given. Can you find the other? You know that half into height is given as 4 into A. A is 10 because one of the parallel sides is 10 plus B, right, is given as 34. So I'm going to equate these two and I can cancel this. So that gives me B is equal to 17 minus 10, which is nothing but 7 centimeters, right? So that is the answer for the second question. Third question, length of the fence of a trapezium shaped field ABCD is given as 120 and 3 sides are given. So because I have 3 sides, definitely we can find the fourth side. Now I want the area, and you can look at the figure. AB is perpendicular to the parallel sides, and find the area. If AD is 40, now this is 40 meters, BC is 48, CD is 17, and I don't know AD, right? Sorry, AD is 40 and I have to find AB. Okay, this is not 40, I have to find it out. AD is given, BC, CD is given, and BC is given. I have to find AB. So if I add these three, I'm going to get 90 plus 105, 105, right? So the total perimeter is nothing but length of the fence is nothing but perimeter. Perimeter is always sum of all the four sides is 120. So I can equate 120 is equal to this AB, which I need to find out, plus sum of all these three, which is 105. So clearly you can see that AB is 15 centimeters, right? 15 meters. All the measurements are given in meters. So this is the length of the perpendicular distance between the parallel sides. So now they're asking us the area, which is nothing but half into height, which is 15, into A plus B. The parallel sides are 40 and 48. So if I add them, I'll get 88, right? And it is meter square. So if I simplify this, I'm going to get 660. So this is the area of this particular trapezium shaped field. So that is your third question. Fourth question, now they have given a quadrilateral, okay, and one diagonal is given 24 and they're dropping perpendiculars from the other two vertices and the lengths are 13 and 8. Find the area. Now you can see that by joining this particular diagonal, we have divided the quadrilateral into two triangles. Now I know the area of a triangle, but in order to use it, I need the base and height. You can clearly see that I know the base and height. So here for this triangle, it is going to be half into 24 into 13. And for this triangle, it's going to be half into 24. Its base is 24 for both triangles into 8, right? So if I simplify this, 12 into 13, right? It is going to be 156 meters square. And over here, 4, the 96 meters square. So what is the total? If I add these two, I'm going to get area as 252 meters square. That is your answer, right? Fifth question, the diagonals are given. Can you find the area? You know that the area is given by half d1, d2. So the diagonals are given to us. So if I substitute those values, I'm going to get 45 square centimeters. That is your fifth question. Sixth question, area of a rhombus whose side is given an altitude. Can you find the area? Now in the previous video we have seen area of a parallelogram is base into height, right? Now every rhombus is a parallelogram, and if you have base, okay, and height given to you, you can find base into height area is nothing but 5 into 4.8, which is nothing but 24 square centimeters, right? Now they're asking, if one diagonal is 8, can you find the other diagonal? Simply you equate this area with the diagonal formula half d1 d2, right? half D1 is given as 8, D2 I have to find out. So if you simplify, you're going to get the answer D2 as 6 centimeters. Therefore, the diagonal is 6 centimeters. The other diagonal is 6 centimeters. That is your sixth question. Next, I have seventh question. The floor of a building consists of 3000 tiles which are rhombus shaped and each of its um, diagonals are 45 and 30 centimeters in length. The total cost needs to be found out. If per square meter, not square centimeter, so whatever area I get, I have to convert to square meter. If per square meter, it is 4 rupees. Okay, let us do this. There's no place here. We have to do it in a separate sheet. So here I have, this is the seventh question. I have 3000 rhombus shaped tiles. Okay. Area of each tile is half D1 D2. Now for a rhombus, I know that this is the formula, and the diagonals are given as 45 and 30 square centimeters, right? And this is nothing but I have 675. This is the area of one tile. Total area is 3000 into this figure, right? Because I have 3000 such tiles. So I will have 2025. Okay. This is the total area. Now the rate is given as 4 rupees per meter square. So for the total so much area, the total cost is going to be 4 into, now this is, mind you, this is in square centimeters. I have to convert it to square meters. So I'm going to divide it, right? And now I have 0, 1, 8, right? So 810 rupees is going to be the required cost, right? So that is your seventh question. Next I have, Mohan wants to buy a trapezium shaped field. Its side along the river is twice the one along the road, and the area is given, perpendicular distance is given. Can you find the length of the side along the river? Now, if you look at the given information here, I have a trapezium shape, and they're saying that one side I have a road, the other side I have a river, right? So I have here, if this is x, this is going to be 2x, because they're saying in the question, they're clearly saying that it is twice. It is twice the side on the other side, twice the along the river, it's going to be twice what we have along the road. So if along the road it is x, and then along the river it's going to be 2x, right? So now this perpendicular distance is given as 100 meters, right? So with this information, we are trying to find the value of x. So I have 10500 is nothing but half h into a plus b. What is x plus 2x? 3x, right? So I have x is equal to 70 meters. That means the length along the river is 2x, which is 140 meters. So that is the eighth question. In the next question, I have regular octagon. Okay. Whenever they say regular octagon, it's very important that you use this information. What we mean by regular, as we have discussed earlier in understanding quadrilaterals, is any regular polygon is equiangular and equilateral. So a regular octagon means all the 8 sides of this particular octagon are of same length. Now they are asking us to find the area. Okay, so again, there is no fixed way to find the area, but you can find the area by segmenting it into known areas that you're already familiar with. So what are we going to do? Let us draw the figure. I have a octagon. It's regular. So all sides, all 8 sides are of equal length, right? And this is given as, so this is 5 centimeters that is given to us, right? And this is given as 4 centimeters. Okay, the measurements are given in meters because you're talking about a field meters, and this light here is given as 11 meters. So what can be done? You can clearly see that this is a trapezium, this is a rectangle, and this is another trapezium. Now by symmetry, this and this are going to have the same area. So this is going to be the trapezium half h into a plus b. Now what is a? A is 5, right? And b is 11, so total is 16, right? So this is nothing but 32 meters square. Okay, third one is going to be again 32 meters square. Second one is a rectangle, length into breadth is 11 into 5, 55. This is very straightforward. And then the third one, I need not calculate, I know that it is 32. So if I add all these three, I'm going to get the total area as 64 plus 55, which is 119. So that is your total area of the octagonal field. That is the 9th question. In the 10th question, they're saying you have a pentagonal shaped park and Jyoti and Kavita are finding the area by dividing it in two different ways. They're finding the area using two different ways. Now, can you suggest some other way of finding its area? You need to, try to come up with, there are more ways of finding the other area by using other methods. And it's very important that you try and arrive at those other methods of finding the area. Now, what is the area if we use Jyoti's method? What we are going to do is, I'll be having two trapeziums. Here I have two trapeziums and the height is nothing but, so it is 2 times of half. Height is half of this 15, right? This is the height, which is nothing but half of 15. So that is 15 by 2. A plus B. A is 15, B is 30. So the sum is 45, right? So this will give me 675 by 2, which is nothing but 337.5, right? So that is the area. Now if you look at Kavita's method, she has a triangle. So half into base, base is 15, height is 15 again, because this from here to here is 30 minus 15, right? So that will give you 15. This is nothing but 225 by 2, 112.5, right? And then I have a square of side length 15, so 225 meters square. That is my square area. So the total area is going to be 337.5. So you get the same answer using two different methods. And in both the methods, you have used different formulae. In the first, you used area for trapezium. In the second, you used triangle and square. Okay. So try to come up with other ways of solving this particular sum. Next, I have diagram of the diagram is given of a photo frame, and I have the dimensions given to me. I need the area of each section. Okay, each of these sections, there are 4 sections here. Okay, each of these sections I want an area. Now each of these sections are trapeziums, right? So if I name this 1, this is going to be the same as this, and if this is 2, this is going to be the same as this by symmetry. So let's look at the first one, half into height. Now what is this height? You can see that this total is 28 and this is 20, which is, the difference is 8, half of 8 is 4. So that is the height. A plus B is 16 plus 24, which is 40, right? This is nothing but 80 square centimeters. So that is the first and third trapeziums, you can say. And for second and fourth trapezium, I have half. Again here, what is the height? This is the height of the trapezium, which is nothing but 24 minus 16, which is 8 by 2, which is 4. Why am I taking only half? Because I have this plus this is 8. So each one is going to be half into A plus B, which is 20 plus 28, which is 48. Right? So here I am going to get 96 square centimeters. Right? So this is the area of each of the sections. The first one is 80, the second one is 96, the third one is 80, and the fourth one is again 96. So with this we come to the, we finish the exercise 9.1. In the next video, we will be continuing with the chapter. We will be looking at solid shapes, and 9.2 deals with the surface area. Let's look at what we mean by surface area and what are the formula for finding surface area of few standard solid shapes.